We're finally going back to Venus.
Yes, it's been a long journey for already. We haven't even left the ground, but for those of us who've been advocating and agitating for new Venus missions. And the good news is that we have several Venus missions, two American missions, Da Vinci and Veritas, which is an orbiter, which very much complements Da Vinci, which is an entry probe that descends down through the atmosphere to the surface. And then there's also a European mission and an Indian Space Agency potential mission. So a lot of agencies are getting into the game now. But the one I'm most excited about, because I'm on the team and very involved with, is this Da Vinci mission, which, if all goes well, will launch in the 2031 timeframe now. I no longer am a NASA employee at the moment, but Da Vinci is very much a NASA mission, which is still moving forward and being built. We have an entry sphere, and some of the instruments are already built. And, it's a very challenging engineering problem to drop something into that intense environment of the Venus atmosphere and have it survive to the surface. Okay, well, if in the upper clouds where the mission starts, we drop it into the atmosphere in a parachute, and in the upper clouds where it starts to operate, it's actually more or less the same temperature and pressure as the surface of Earth, like in the room you're sitting in now. But as you drop down, it gets hotter and hotter to the point, and higher and higher pressure, to the point where when you reach the surface, it's 900 degrees hotter than the hottest self-cleaning temperature on your oven.
Fahrenheit.
And it's almost 100 times the surface pressure of Earth. So crushing pressure, searing temperature. And by the way, those clouds you drop through are made out of concentrated sulfuric acid, like battery acid. So you have to be able to withstand all these crazy environmental factors. A lot of the important part of this mission is involving measurements of the atmosphere that have never been made before. Because again, we haven't been able to operate that much in the Venus atmosphere because it's so forbidding. So we've never had modern instrumentation, never had 21st century instruments that can really tell us exactly what those gases are made out of, exactly what the isotopes are of hydrogen and what the rare gases are, all these things that really can be diagnostic of the history of the planet. We've never measured them well. We have an imaging system where we do the first ever descent photography, like really high resolution stereo descent photography of this very mountainous area where we're going to land. We're going to do that for Venus, except again with 21st century cameras, and it's never been seen before. And this is going to be a very dramatic mountainous region with really cool and revealing topography. Well, we are going to crash.